Hey y'all, today we're going to talk about life histories. Life history is a record of major events related to growth and development, reproduction, and survival, three really important terms. Growth and development include things like speed of metabolism, speed of juvenile growth, and size at maturity. Reproduction is things like how many offsprings you have, age at first reproduction, and frequency and number of reproductive events. Survival includes the cost of reproduction, lifespan, and juvenile versus adult survival. This is the graph to show life histories. This graph has three different axes: fecundity axis, age of reproductive maturity, and extending downward is the juvenile survivorship. An animal that has a lot of offspring would be high up on the fecundity scale. An organism with a reproductive age of 15, such as human, would be farther right than an ant, for example, with a reproductive age of 2 years. Lastly, the juvenile survivorship is essentially how many chances you have of surviving in your earlier years or how young you might die. Take Nemo, for example, who was one of the 1,000 fish eggs. He was the only surviving fish, which would put him at a lesser juvenile survivorship scale. Take all these variables into account from this graph, and you can get the equation of life history vital rates, which is this one right here. T is generation time, X is age at maturity, LX is survivorship, MX is fecundity, which is number of offspring, and R sub 0 is net reproductive rate.
There are three main types of life histories: opportunistic, equilibrium, and periodic. Opportunistic looks like this on the graph. It combines low juvenile survivorship, low fecundity, and early maturity. An example of an opportunistic species is a guppy. Opportunistic species have maximized colonization abilities in unstable environments. Equilibrium species are around this area on the graph. They combine high juvenile survivorship, low fecundity, and late maturity. Most large mammals have equilibrium life histories, for example, elk. Periodic looks like this on the graph. They have low juvenile survivorship, high fecundity, and late maturity. They have maximized colonization ability in infrequent favorable conditions. An example would be crocodiles. We can classify life history strategies using K and R selected growth. Just like K and R selected species from the logistic model of population growth we discussed last lecture. There are always trade-offs between growth, reproduction, and survival. For example, current growth would use up energy and may lower or delay reproduction. Also, deferred investments may never be realized. One common trade-off is that size and number of offspring are usually related. High number of offspring will usually be associated with small-sized offspring, as can be seen in many R-selected species. Another is between growth and reproduction. For example, early maturity will often result in a slowdown of growth. Humans can also play a big role in life histories. With the Northeast Arctic cod, we saw in class how the fishing industry has reduced the age the fishes reach maturity because humans catch the largest fishes, so the fish will have a better chance at reproducing when they are smaller. Also, because there are multiple ways to solve environmental challenges, different solutions can result in a mix of life histories within a species. Basically, life histories respond to natural selection. They will be shaped by adaptations to the environment and can include phenotypic plasticity. So that's life histories.